Hello, everyone, and welcome to the March 2025 Integration Down Under. Today we've got myself and Dan. The other organizers are Martin and Mick and Wagner. I know that Mick and Wagner are over in the US at the moment at the MVP Summit. I don't think Martin's over there, but today, Dan is going to be talking about building an AI RAG application with Logic Apps. And this is something that I'm glad Dan's doing because I've seen several things on this and I've been wanting to do this, but now that Dan's done it, I can just listen in and learn all about it, which is good. So let's hand over to Dan and let him get started. Dan,
Okay.
welcome.
Thanks, Bill. Thanks for that intro. Yep, as Bill mentioned, today we're going to talk about building RAG patterns with Logic Apps, and I might add that it is virtually no code involved, which is pretty good. So just a little bit about me. I'm a senior integration specialist at Deloitte. Senior mainly because of my gray hair, not so much because of my wisdom or experience. And bunch of other boring things there, but the picture tells you about one of my the way I spend a lot of my non-work time. I'm very involved in my church ministry, and one of those ministries is playing piano for the choir. So that's good. I'm a bit of an ex-muso, but piano was not my main instrument. I just that was always my secondary. But the good thing about playing in church is that they can't fire me. So they can put up with my amateur piano playing. I just wanted to shout out to Stephen Thomas on here because a lot of the material that I'm going to present to you tonight is really based on the work that Stephen has done. So he put together a really fantastic video and webpage about how to build an ingestion pattern for the RAG workflow, and that's how I learned it. So I'll give you a pointer to all of his resources later in the deck. But if you don't know Stephen, he's been an MVP in the integration space for about 20 years, and he's a very prolific presenter, author, and a trainer. So based on his content, I went in 1 week from being an AI illiterate to someone who can smugly drop words like vector database and actually pretend I know what that means. So there we go. So if you, as I mentioned before, if you were been in the AI space, if you probably would have heard about RAG, it would have come up. If it hasn't and you don't know anything about it, don't worry, because I'm going to go through it. I'm going to go through the whole concepts about that and how it works. Talk very briefly about Logic Apps because I'm assuming that most of the people who are tuning into this webcast will probably already know a fair amount about what Logic Apps are. But I'll cover that briefly, and then I'll show how we can build RAG with no code, and no prizes for guessing what technology is going to help us do that. Okay, so RAG. RAG stands for Retrieval. Sorry, hang on, something's happening with the slide here. RAG stands for Retrieval Augmented Generation, and what that. Before I explain exactly what that is, let's talk about how we typically engage with AI services. Such as ChatGPT, for example. So we have what's called an LLM, which stands for Large Language Module. And that basically is a large language module is something that has been trained on a set of data, and it has the ability to converse in natural language. So it can understand queries in natural language and communicate in natural language. And probably everyone who's on this webcast would at some point, worked with ChatGPT or something similar to it. So the way it typically works is a user types in a prompt or a question or a query, and whatever interface that is, that massages that query to talk and to prompt engineer it a bit so that the LLM can understand it better, and submits that question. And the LLM uses the data that it's been trained on and its skills in natural language to formulate a response that gets sent back to the user in plain English. Now, you hope the response is useful and correct, but one of the problems that we have with this is the fact that you rarely ever know where that data came from. So, for example, if you're using ChatGPT, it's probably largely trained on the internet. So, but it rarely comes back with citations about where it gets its information from. So you're kind of hoping that the information is correct. And if the information even was correct at one time, you're hoping it's still correct at this time, because without sources, you don't really know if the information is current or not. And the other problem too is that you hope that the answer is somewhere within the context of where you're asking the question from. Now, a lot of that has to do a bit with prompt engineering and making sure that your prompt is particular enough so it can confine the domain that it answers in. But again, without the citations and stuff, it's a little bit hard to know that. Now, if you're a large organization or enterprise and you can afford to build and run your own LLM and train it on your data, that helps solve the problem a little bit. It handles the first and the third point fairly well because you can trust your information, and you can, most likely it's going to be in the context of what people are asking questions for within your company. But even the currency is still a bit of an issue, because the problem with LLMs is that retraining them on, say, updated data, for example, is a fairly expensive process to do that. So again, you have the problem of managing currency and all of that. So this is where the Retrieval Augmented Generation model comes in. So what we add to this picture is a set of contextual data, which the company manages. And that data can be anything. It could be documents, it could be a database, or anywhere that you can pull data from. And what you do is you put in front of that a very intelligent search service, so that can be able to find that information. Now, what happens is when the user submits the query to the query interface, instead of going directly to the LLM, what it does is it sends its query to this search database, and the search intelligently goes and looks through the contextual data and finds all the information that it thinks is relevant to your query, and it returns that, and then the interface then sends that to the LLM with the extra information. Now, what this is doing is telling the LLM, I want you to answer this question, but I want you to answer it from the data set that I'm giving you. And if you can't find the answer in there, then just come back and say, I can't find the answer. I don't have enough information. Don't just go out to the internet and try to enhance it or augment it, or worse yet, hallucinate it. So the good thing about that is you not only get a better quality response that's confined to the boundary that you want in your domain, but it also has the ability to send you back the actual sources and the citations and say, this is the answer to your question, and this is the document that I got it from. So you can understand how valuable this is to organizations. Now, one of the key components in that is that searching capability, to be able to intelligently correlate the question you're asking in the query with the information that's in the contextual knowledge source. So there's a couple of terms that we need to kind of get across. If you've been working or anywhere near the AI space, you've been probably hearing terms like embeddings and vectors and tokens. So in case you don't know what that is, an embedding is really just, it's a piece of knowledge. It's information, a bite-sized bit of information. And that information is stored in as numbers rather than as text. So what happens is those text strings are converted to vectors, and a vector is just an array of numbers. Now you might ask why we do that. The reason is because the way the search algorithms work, it's much more efficient to be searching and correlating numbers than text. It just makes it a lot more efficient. So all of this gets stored in what we call a vector database. And in the vector database is very, very good at locating information close to each other. So it's proximity aware. So this image, which I stole from a video on that link that's at the bottom of the slide, is a Cooper Codes YouTube channel. This is sort of an illustration of how you might picture a vector database working, in that each of those dots represents an embedding, a bit of information. and it groups them together according to how the database thinks they relate to each other. So for example, it's kind of hard to read that image probably if you have a small screen, but the green dots in this case are athletes, the blue dots are film, the purple dots are transportation. So this is where the intellect comes in figuring out what relates to each other. And that way, when you submit queries to it, it knows how to find information that's relevant to your question. So when you think about artificial intelligence, a lot of it really is based on association, on the ability to associate different things. So this vector databases are really, really handy, in fact, quite crucial in being able to do this if you're looking up information. So one of the links I got from Stephen W. Thomas's page was a link to this 5-minute video that explains OpenAI embeddings, and I really recommend you have a look at it. It's really quite good the way he goes and does this explanation. So you might want to check that out, and I'll be sharing these slides somewhere after the presentation. So if you're going to make this work, it's important that that we have that really good search capability over that information, and the vector database helps. So, but we also, when we add documents, and this is the good thing about RAG, is that you only have to update your knowledge store. You don't have to update the LLM. So it's easy to keep your data current. But to do that, you have to have, every time you do change data or add it, you have to then ingest it so that you can index it properly in your vector database. And there's a workflow that takes care of that. So first is your data acquisition. Then what you do is you tokenize that data. And tokenization is really nothing more than taking your data and cutting it up in chunks. And this can be quite arbitrary. You give it a token size, say, I don't know, 5,000 characters or 5,000 bytes or whatever. And it will literally just cut up your document in those bytes and send them in. And those are embeddings. Those tokens become embeddings, and they're translated to vectors, and then they're stored in the vector database and indexed so that they can be looked up easily. So that's one part of the issue. This is how you then create your information to be searched. But then there's the actual interaction with it, which is when you actually want to ask it a question. So that workflow is basically capturing your query, maybe doing a little bit of prompt engineering on it to fine tune it. You then need to take the query and turn that into embeddings. So they become vectors, so that you can then send it to your vector database and say, find me the information that's relevant to this query. And then through that, you then get you then compile all that and get a prompt creation that you then send to your LLM. And that's the chat completion. So the chat workflow looks more complicated than the ingestion, but actually the ingestion process is a little bit more complicated in itself. Now, to build all of this, you can do this in code. And there's plenty of libraries out there and platforms that will allow you to do it. But it's a lot of code. Or you can find a solution to build it with minimal or no code at all. And that's what we're going to cover in this presentation. And to do that, we're going to make use of one of the most prolific integration services that Microsoft Azure has to offer, and that's Logic Apps. We're talking workflows here, and that's exactly what Logic Apps does really, really well. It's how you orchestrate processes. They're durable, they're long-running, they're very, very scalable, they're very, very robust when they run. So this is an excellent technology to use. And one of the cool things about the Logic Apps is that it comes bundled with hundreds and hundreds of adapters, so that you don't have to write code to interface with the APIs for these services. So you've got connectors for your protocol ones like HTTP, SFTP, SOAP, and all of that. You've also got a connector for just about every Azure service and a lot of other Microsoft services and applications as well. But then the largest part of it is the third-party SaaS services. And this is not even a quarter of the connectors that are actually available now. You can never keep this list up to date. So logic apps, boast their ability to connect to anything. They can connect to Azure services, Microsoft services, SaaS services, and even with an on-premises data gateway, they can reach down into your on-premises, and you can have hybrid applications built that way. So I'm just kind of rush through this because, as I said, probably most people watching this know what logic apps are. You build the workflows in the browser, or you build them in Visual Studio Code too if you're building standard logic apps. Logic apps always have a trigger and they have actions. The trigger is what always kicks off the logic app, and every logic app has to have one. Could be a schedule, could be a direct call, it could be responding to an event. And it's quite capable of doing all the kind of programming patterns that you would normally do in any workflow. So you can do conditional statements, switch statements, loops, exception management, fan in, fan out, all that kind of stuff. Now, what really helps here in the AI space is that two of the connectors are Azure OpenAI connector, which is basically your LLM capability in a Azure cloud, and Azure AI Search, which is that intelligent search that we need. So you've got connectors, and you can tell by looking at the operations here that are available that this would be extremely useful in building a RAG workflow. And that's exactly what they're handy for. That QR code, by the way, will take you to a page that talks about OpenAI support in Logic Apps. The other thing that's really handy in Logic Apps that we have now are templates. So when you go to create a Logic App, you can either create one from scratch, or you can actually select a pre-built template that gives you kind of an accelerator, a kind of a hit the ground running type of a start to building your Logic App. And there are heaps of them available right now, so much that they actually you can filter based on categories. One of the categories is AI, and if you select that, you'll see that the first 4 or 5 templates that come up all have to do with the RAG pattern. In fact, you can actually search on the RAG category too. I discovered that after I made this screenshot. So those two things really are going to help you with building RAG patterns in Azure. So let's go back to the model components. So the Azure OpenAI is basically your LLM, and there's a number of different models that you can choose and select from to use with OpenAI. We then have to have a place to store our contextual data. Now, that can be any kind of storage. I think it supports all the database stuff like Cosmos and DB and SQL database and all. But for this particular demo, we're just going to use blob storage. But there's a number of options there. And then, of course, our smart search service is Azure AI Search, which can be your vector database. And then the workflow that ties it together is Logic Apps. And we're going to use standard Logic Apps here. I do believe that the connectors will work with consumption Logic Apps as well, but one disadvantage with the consumption one is you don't get the templates yet for RAG being available with them. So we use a standard Logic App here, and that, of course, comes bundled inside of an app service plan. Now, one more thing to be aware of is that with this demo and with using these services, you kind of need to keep everything in one region. With the Azure OpenAI, I'm not sure. I think that might be able to be in another region, but I don't think either Stephen or myself has tested that yet. But generally, it's just a lot simpler to find everything if you keep it all in the same region. So now if we go back to that RAG model that we had before, and if we overlay it with the Azure services, we can see that everything kind of fits. So you've got your contextual knowledge store in Azure Blob Storage. You've got your AI Search doing the vector database over it. Your LLM is basically Azure OpenAI, and Logic Apps is basically the interface that's tying everything together. Now, this is representing the ingestion and, well, actually both the ingestion and the chat workflow. Okay, so let's look at the ingestion workflow first, because that's the key in being able to get all this documents and this information accessible so that you can pull it up and send it to the LLM. So the particular template that I'm using is this one, which works with blob storage. But there are 4 or 5 of these different ones available for ingestion with different kinds of triggers and sources of data in it. So there is also one template available for being able to chat with your documents. So this is after you built the ingestion and now you want to interact with the LLM. There's a logic app that handles that as well. Okay, so let's look at the structure for the ingestion workflow. So it starts with being able to respond to an event, which is when a blob is added or updated in your Azure storage. You read the data from the blob, you extract the text from the input, and then you chunk that text. So that's how you create these sort of bite-sized tokens, and you get to set the token size in the app. Then you create your embeddings for that using OpenAI, and the embeddings, again, remember, are the turning it into vectors, which are number vectors. And then with that, you need to, in order to interact with Azure AI Search, there would be a certain schema for how you need to present those tokens. So you just need to map your embeddings into that search schema, and then you send it to Azure AI Search, and that captures all that data and indexes the information so that it becomes available. Now we can kind of see how that maps to that workflow that I showed you earlier. So how do you build this? Well, this is where it was really helpful with Stephen Thomas, and he created this video that goes through the whole process step by step, and not only creating the logic app, but he actually shows you how to set up OpenAI and Azure AI Search in Azure, which is, of course, a prerequisite for everything. That's usually the hard bit for everyone. So this is a really, really excellent video. And a testament to how effective it is. I went through this when I set up the demo, and everything worked the first time perfectly. And there's quite a few moving parts, so that's really saying something. So if you go to that page, you'll get all that information. You'll get the video. He's published his list, his high-level task list of what to do, and some links to learning resources as well. And just a few important things about this. I mentioned already that we create all of the resources in the same region. That makes everything a lot easier. Permissions is really a big part of this, because you've got all these 3 or 4 services that need to talk to each other. And getting the permissions right without just giving everything God mode, which you never do, right? So least privilege idea. Managed identities are really, really helpful in this. It makes it so much easier to link everything together. And then he talks about how you capture the key details. And those key details, well, first, there's the permissions. So these are the role assignments that are necessary that you have to configure for everything. So you get a nice list of that. And then these are just the configuration points that you have to plug in when you actually build the model. So this is how everything will tie together configuration-wise. So all of this is for the ingestion workflow. So what I'm going to do now is actually show you that, I think, before. Well, no, actually, I'll do this first. I'll go through briefly the chat workflow. So once you built the ingestion workflow, and Stephen Thomas shows you how to do all of that, then it's just a matter of using the chat workflow. And I was able to use this pretty much straight from the template. So Stephen didn't cover this part, but it's much more straight ahead than the ingestion one. Because by the time you're building this, you've also set up already your Azure AI Search and your OpenAI and everything that you need. So that helps an awful lot with it. So with this one on the chat, you have your trigger, which is basically a query. And then you get your embeddings, you turn it into vectors, and then perform a search in AI Search with that vector to find the relevant information from your knowledge store, extract the content from that search, and send it on to your OpenAI or your LLM to get the chat completions, and then return that to the caller. And you can see how all of that maps very, very nicely to that workflow I showed you before. Okay, let's go into demo mode. Now, you should be able to see my browser open to Azure AI Search. Is that all good, Bill?
Yep, that's good.
Okay, great. So this is the Azure AI Search. Actually, what I'm going to start first is with the knowledge store. So I've got a blob storage account, and I've got in there a folder called input, and I've got a couple of documents in here. So these are documents about a fictitious company with some policies and your health benefits and stuff with that we're gonna search. We have Azure Search that has been pointed to that data source. Okay, the Azure blob storage. We've got an index. Actually, we've got a couple of them, but we're going to be using this index here, AI Demo 3. You can see that it says there's 27 documents in there. And you're wondering, well, what's that? Because I only saw 3 in the blob storage. But remember that that part of this process is tokenizing those documents. So when it breaks it up into different tokens, then that's considered documents in here. So it can relate. So we have that index that's in there. And one of the things I was going to call out is when you define your index, you also define a schema that for how you interact with that index. So what you have here is these 5 fields here. So you have your chunk ID, that's just an identifier. The chunk is the actual data or the token. The parent ID is not really used in this demo, but I guess you can kind of link or relate certain tokens together. And then the text vector is the actual vectors of the information. So those are those arrays of numbers. Okay, and I have an Azure OpenAI Search service, Azure OpenAI service available, and with that we have an Azure AI Foundry, which allows us to interact with the data. And then we have our logic app. So if I go into here, okay. So this is, in my workflows, this is the ingestion workflow in a logic app. And just taking you through it briefly, this is an event that it reacts to when a blob is added or updated. It reads the content from the blob. It parses the content from the blob. That's all very, very straight ahead. The chunk text, basically, is what actually breaks all of that up into byte size. And here you can specify the token size. So I just chose 4096. That seemed to work pretty well. It worked pretty well for Stephen. And then what you do is you take those tokens and you submit it to turn them into embeddings, which is your vectors, right? And then what you need to do is map those embeddings to the schema that is consumable for the Azure AI Search. So you see that kind of matches those fields that we have here. And then you submit that to your search index, and that's the ingestion workflow. So there's no code involved in any of this. If I want to run this, which I will in a moment, I can use this to add some documents. But what I'm going to do right now is I'm going to use the chat playground and kind of show you how the search works. Now, by default, when I'm using ChatGPT, it's actually getting its information from it's getting its information from the internet, right? There's no context boundary at all in here. So if I type a question like, does my plan cover eye care? Okay, well, it's not really going to be able to answer that because it doesn't know what the context is, and it's going out to the internet. But if I want to get that context from my data, what I can do in this playground here is I can add my own data. I can add a data source. So this is effectively doing kind of a simulation of a RAG model, basically, where it's going to take the data that I ask to send to it and attach that to the query. So it's finding my Azure search. I'm going to choose the right index, which is number 3. I'm going to say add a vector search to this research, and I'm going to choose the embedding model. I've only got one that I've chosen. I don't need to do a custom field mapping. Go next, and I'll keep the search type as hybrid and semantic, and just choose my search configuration. And that's pretty much all I have to do. Oh, yeah, and I'm using a system assigned manage identity for it instead of an API key, which is much better. Okay, and we'll validate that, and there we go. So now when I ask that same question, it's now going to use the data that I have in my data store, which is from those documents that I've uploaded into the blob storage. So hopefully I'll come back and it will actually find that information in that document. Yes, so now it's saying that yes, the Northwood Standard Plan includes coverage for vision services, which encompasses eye care. And if you notice, I've actually got a reference, I've got a citation here, and it's actually telling me what document it is that it got that information from. So this is kind of the beauty of being able to have that RAG model. Now, obviously, you're not going to use AI Foundry in your production. So what we need is a way to do these queries in a proper service. And that's where the other Logic App workflow comes in. So if I go back to my workflows, I need to have a Logic App that's going to do that query for me. I've got one built already, but I'm actually just going to go through, if we have enough time. We're doing okay on time, aren't we? I'm actually just going to build it in front of you to show how easy that is. So I'm going to go add, and I'm going to go add from template. Okay. And what I'm going to do is I'm going to limit my search. I could limit to AI, but there's actually a RAG category in here. So if I choose that, you can see that's whittled down the number of templates available. And there's a template here called RAG chat with your documents. So we're going to open this. And when you open a template, it actually gives you an example of what the Logic App flow looks like. And if I go into the summary, it's going to tell you what connections that it requires. Now notice it's saying connected. And it's saying connected because I already have those connectors available in this Logic App because I used them in the ingestion workflow. So it's found them already for me. It tells me exactly what it does and how it works. So if I want to use this template, now I've got to tell it whether I want it to be stateful or stateless. This is just a query over data, so I think stateless will be fine. There's less storage involved with that. A little bit better performance potentially. It's going to check the connections. Now, if I didn't have these connections, I would be prompted to create the connections that I need for this workflow. But since I already have them in the Logic App, it's found them and said, yep, we'll just use these. And that's perfectly fine. Then we'll go next. And now we have some parameters. Now, this is the bit where I got to get it right. I've got to be able to give it the index, the proper names for what I need. So I'm just copying from an offline screen here, but I know that my index, the one that I want to use, is that number 3 one. The deployment model is actually, I think it's this one. Hopefully I don't get it backwards. This is where it's a little bit tricky because, yeah, that should be the right one. Because this one especially, it took me a couple of goes to work out what it was really asking for here. When you deploy a chat model, there is it's actually looking for the deployment name for that. So if I were to go into, I think it's here, and I go into, sorry, no, it's not. Vector, let me go back. It's in, no, maybe it isn't here. Resource management, there should be deployments somewhere. Okay, where did I have that? It had to be either in search or it had to be in, Search management settings. Okay. I remember it was in. Sorry, it was in. It was in here, AI Foundry. If I look down here in deployments, these are the actual deployments. So there's two deployments that are involved in this OpenAI. One was for the embedding. So this is how we create the embeddings. And then one is the actual chat model, and that's GPT-4. And that's what we need, is this name, not necessarily that name, because they can be different, right? Now, as it happened, I just chose the same name as the model name. But getting that right is very, very important, or else it's not going to work. And I click next, and then just review and create. What am I missing? Previous. Basics. It says basic. What am I missing? Oh, of course, I didn't give it a name. That's right. So we'll just call this query documents. Okay. And say next, and now it should work. Next, create. All right, so it's creating my workflow. Now, I will have to tweak a couple of things in here to get it to work right, but it's fairly minor stuff. Okay, just waiting for that to finish loading. You can see that the trigger here is when an HTTP request is received, and it gives you the schema for what the request message should look like. So it's just basically a JSON object with two properties, prompt and system message. Prompt is where you enter your query, your string. You leave system message blank because when it comes back, that's going to fill it out with the response. So there's nothing I really need to change in there. I will remember to copy that URL because that's how I'm going to be able to engage with it, but I'll come back to that in a moment. This now gets, Azure AI gets a single embedding. So this is actually where it's turning the request into an embedding. And then with the Azure AI Search, we're going to use that embedding to actually search. Now, this is the first thing I need to change. With the model that we're using, it's not going to be embeddings. I need to change that to be text vector because that's what's being used in the schema. I find if you forget to do that, you're just going to get 503 gateway errors all the time, and you won't even see anything showing up in the trigger instances when you just fails and you don't know why. So that was a bit tricky to get that. Then we want to extract the content from what we get back from AI Search. Now, the default that they put in here doesn't match the schema that AI Search is using. So I just need to change these two properties. So instead of ID, it's chunk ID. And there will be a blog post coming to explain all this within the next week, I hope. And then this is actually called chunk. And again, how do I know that? That's from that model that we had here where we looked at the index and we had the fields. So this is what we're trying to match. Okay, so I've made those changes. Then I have the chat completions. I don't need to, that's getting off, actually sending it to the LLM to get the actual response. And I don't think I need to change anything else. That should be it. Okay, so we're going to save this. And now that I've saved it, I'm going to copy this URL and I'm going to go into my Postman and we'll replace this URL with the new one. And I'm using the same query. So this is my request. It's a post operation, and hopefully this will work. Obviously, the first time it kicks up, it's got to be a little bit slow. There we go. There we go. All right. Yes. So your Northwood plan. So I just built that chat workflow right in front of you, and it took me what 10 minutes to do it. So that's actually working. Now what's missing here are the citations. That's in the default chat workflow doesn't cater for that at the moment, but that's something that can easily be expanded, I'm sure. But you just from using the template, we got up and running very, very quickly with that. Before I go back to the slides, does anybody have any questions?
There's no questions posted out there.
Okay, fantastic. So let me go back to my slides. Okay, you should be able to see demo, right?
Yes.
Okay. Okay, so a few things to be aware of. I've mentioned before that it's a lot simpler to do this if everything's in the same region. Some of these services have to be in the same region to talk to each other. Some might not be, but it would be. But we haven't tested yet with the OpenAI one. Using managed identities is a big, big help here. You basically just set up a system managed identity for each one of your services, and that makes it so much easier to link when you're creating the roles assignments. Also, when you're choosing your ChatGPT model, some of them have fairly limited token rations available in certain regions. So if you find you're running out of tokens, you might have to change your model. Fortunately, the one that I picked seemed to be working pretty well. Then the OpenAI model name is not equal to the deployment ID. What it's really asking for is the deployment ID, though it isn't obvious in that prompt. So that's something that I'm going to blog about just to make that clear for people. It's apparently a common mistake. And getting all the permissions right is absolutely key. That's usually where this thing falls over when people are trying to do it. So that's pretty much wraps up what I wanted to get across. RAG, you can see now what the benefit is of using a RAG model in terms of giving you much better query results that are confined to a specific domain with reliable data. And the best part is it's fairly easy to update that data. That's what I didn't do in my demo. We have time. I can actually show what happens when you and update the model. I was going to run the ingestion workflow, wasn't I? Okay, let me go back and do that. I always forget to do something in the demo. Okay, so I'm going to go back and to query, and I'm going to ask it another question. I'm going to say, does my employer offer gym memberships? Okay, now I know for a fact that the documents that I have in there at the moment don't have that information. So it's come back and it said the provided text doesn't mention anything about your employer offering gym memberships. Okay, so that's actually a better answer than I expected. I expected to come back and say I can't answer a question because I don't have the information. But if you can see this document, there's a document called Perks Plus, and what's covered. And in here, we actually have gym memberships offered, and it talks about it. So this document doesn't yet exist in my knowledge. It hasn't been uploaded to storage yet. So what I'm going to do is I'm going to upload that now. Just give me a second to find the document. So I'm going to take my Perks Plus document, and I'm going to, I can tick overwrite if we want, but it's not there anyway, so that should be right, and upload that document. Now, once I've done that, I should be able to find in my process documents workflow that it's going to trigger it. Yes, see, it's running. It's responded to the fact that a new document has been added, and it's running that right now to ingest that document and add it to the search index. And it probably will finish pretty quick. I'm hoping it will finish pretty quick. This is a pretty small document. And also, while we're doing that, I'm going to go back and we're going to note that there's 27 documents is what it had before. When this finishes, and it should finish pretty quickly. Doesn't usually take that long.
It's a demo. It always takes longer than it should.
This service wasn't warmed up. That's right, because I did the chat one, then I ran that, but I haven't run this. Yeah, just hoping I didn't break something. There we go.
There it is.
It took quite a long time. If we go in there, you can see that all the shapes that it did. So we got everything done. So it's called the index multiple documents. Now, I do know that it can take a minute or two for that index to update. I'll just refresh this. It probably still says 27. So let me go back to the slides and finish out the deck, and we'll come back to this, and then I'll show you that it's actually in there. Okay. All right, so that was my summary slide. I've got a slide here with a bunch of helpful links. Most of these are on Stephen W. Thomas's page as well, so you can find a lot of that information there. If you want to get in touch with me, those are my details. That QR code will take you to my LinkedIn page. And still no questions?
Nope.
Okay, let's go back and see what we got here. There we go, 28 documents. Now, it only needed one token because that was a pretty small document. So 28 is about right. So now if I go back in and I perform the same query, does my employer offer gym memberships? Let's see what it comes back with. Hopefully it'll come back with something better. Yes, your employer offers gym memberships through the Perks Plus Health and Wellness Reimbursement Program. So what I've demonstrated for you is how easy with a RAG model you can update your information. Didn't have to change anything in the LLM because that's difficult to do and retrain it. I just simply had to ingest these documents, and then that document would have been included in the context of when the query was sent to the LLM, so it was able to find the information. Great.
Very good.
That's pretty much all I have, yeah.
Okay. Let me just drop that out and add the questions to the stage and put us back in there. Thanks very much, Dan. That was good. I've got a couple of really neat ideas because 6pivots published their employee handbook out on the internet for people to look at. And it would be interesting to throw a AI chat bot on top of that so that you just don't have to dig through the document. But if it's out there, you could just basically use the chat bot to check things.
For sure.
Yep, that'd be a neat little idea to do. So thank you very much, and that was good. That filled in some gaps for me on some of the stuff that I was looking at doing. And because I saw some of the Kent Weir did some stuff too, along with Stephen Thomas on some of this stuff, and it was good. So, and let's see, that's all that I think we've got. You got any other thing you want to add, Dan, before we finish up?
No, not today.
Okay. Thanks everybody for attending, and I will have this up on our YouTube channel shortly, or a little bit later tonight. Got to go take the dogs for a swim right now, but as soon as I'm back, I will put that up, and it'll be in our playlist on the YouTube channel.
Awesome.
I'm going to end the session. Thank you, everyone, for attending. Bye-bye.